Here's an example of graphing a log, and they give us 4 options, kind of a multiple choice graph thing. So let's get straight. What does a log graph generally look like? So log base b of x. What's the general look? Let me add to it a little bit of let's call this a. So let's give it that general. Try to do that a little bit better. Better writing here. So basically, this, whatever's in the parentheses, and I know we have nothing in the parentheses here, which really means we have plus 0, right? This is log base 5 of x plus 0. So whatever's in there with the x, the opposite of it, so, oops, the opposite of it, so negative a, is the vertical asymptote. So whatever's in the parentheses with x for a log function, the opposite of the number next to x, that's going to be the vertical asymptote. Why? Because if you plug in negative a for x, what are you going to get? Log base b of negative a plus a, meaning log base b of 0. Okay, so why is that a problem? Well, try it on your calculator. Try log of 0. You'll get an error. So that's because that's where the vertical asymptote is. So you see how the opposite of what's next to x will make the inside of the log 0, and the log of 0 is an error. It's because that's where the vertical asymptote is on the graph. So that's the first thing to know. Now, in our case, we don't have anything in the parentheses with x, which means 0, which means, still means something actually very important. Let me do a better job on this graph. It means our vertical asymptote is right here at 0. So there's our vertical asymptote because that's the number in the parentheses next to x. There's nothing, which means 0. Okay, so we know our vertical asymptote is there. So right away, do you see that we know this is not the right graph? See, he has a vertical asymptote somewhere over here. And this one has a vertical somewhere over here. That's not correct. This one has a vertical right at 0. That's a possibility. And this one also has a vertical right at 0. That's a possibility. You can tell, right? The graph is conforming. It's following the vertical asymptote like a guide. It's being guided right at 0 and right at 0 here for those two. So it's going to be one of those two. How do we figure out which one? We got to plug in. So, oh, and I didn't finish this off. So generally, log graphs look like this. They go to their vertical asymptote. They hit some kind of point over there. Now, they can be flipped. Like, you know, they can go like this as well. So it could be either one of those. So that it just depends on the specifics in the log function, which way it goes. But the point is they always rocket up or down at their vertical asymptote. So let's take our particular one, log base 5x. Let's make a little xy chart over here. And let's plug in, let's start with 0. So we'll get y equals log base 5 of 0. Now, we don't have a log base 5 button on our calculator, do we? So what you need to do is turn it into 2 logs with the base on the bottom. So you make it 2 logs base on the bottom. So make it into 2 logs base on the bottom, and when you do, you'll get error. We already talked about that. I'm just going to say that's our vertical asymptote, right? That's an error. All right, so now let's go up by 1. Now go to 1. So we'll get y equals log base 5 of 1. Again, turn that into 2 logs. Log 1 over log 5. See how the base goes to the bottom? The base goes to the bottom, base to the bottom. So you make it 2 logs because we don't have a log base 5 button on our calculator. So you got to make it 2 regular logs. When you do that, you get 0. So over 1 up 0. Here it is. Over 1 up 0. But this one has it too. Over 1 up 0. They've both got that point. So they're both still candidates to be the right answer. So let's go to like 2. When we do 2, I'm going to bring it over here. Y equals log base 5 of 2. You know what to do. Make it into 2 logs. The base goes to the bottom, base to the bottom, because it's the base. Base means the bottom. Like the base of a table is the bottom of a table. So if you hit the buttons, I'm going to do that one on my calculators. I don't know that one. So I'm getting, let's see here, log 2. Then you got to divide that by log 5. I'm getting 0.4. I'll just say 0.4. It goes 0.43 and so 0.4. So over 2, up 0.4. Over 1, 2, up. That should be up right about here, right? Over 2, up 0.4. And the graph it's going through something negative down there. That's not right. Whereas this one, perfect. See that one? Over 2, up 0.4. It goes right through that point. So this is our answer. This one is not the answer because it did not. Here's the real point, over 2, up 0.4. The graph did not go through that point. So here's our correct answer. So we got this point, which determined it. So the vertical asymptote was 0, and we got the point over 2, up 0.4.